What if I told you the most mysterious objects in the universe are built from shockingly simple ingredients? Forget exotic matter or alien elements. We're diving deep into the heart of black holes to uncover the cosmic recipe that forms these gravitational behemoths, revealing a surprising truth about their elemental makeup. Welcome to our channel, where we take you on an exhilarating journey through the cosmos. Join us as we explore the most mind-boggling phenomena and intriguing questions about the universe that have ever been asked. Today, we're addressing one that's been perplexing astronomers for decades. If you're ready to unlock the secrets of the universe and unravel the mysteries that lie within the very essence of black holes, then fasten your seatbelts and prepare for takeoff. Beyond the event horizon, what are black holes? Imagine a place where time stands still and gravity's pull is so strong, not even light can escape its grasp. That's what lies beyond the event horizon of a black hole, a region of space from which nothing can escape once it crosses that boundary. But what exactly are these enigmatic objects that have fascinated scientists and space enthusiasts alike? In simple terms, black holes aren't actually holes, but rather incredibly dense regions of space-time, with gravity so intense that not even light can escape their clutches. They're born from the remnants of massive stars that have exploded as supernovas, leaving behind a collapsed core of extreme density. But how do these celestial objects form, and what's their composition? Before we delve into the surprising truth about their elemental makeup, let's first understand the mind-bending nature of these cosmic wonders. The stellar graveyard. How black holes are born. Stars, like all celestial objects, are born from a cloud of gas and dust that collapse under their own gravity. As the cloud collapses, the material at its center becomes incredibly dense and hot, eventually reaching temperatures and pressures high enough to initiate nuclear fusion. This is the birth of a star. Massive stars live fast and die young. Their brilliant lives end in a spectacular fashion with a supernova explosion that blasts a significant portion of their mass into the surrounding space. What remains is a dense core that could be several times the mass of our Sun, but now fits into a space only a few kilometers wide. This core is mostly made of iron, which is the end product of nuclear fusion in a star's core. But how does this iron core turn into a black hole? To answer this question, we need to look at what happens after a star runs out of fuel. When a star like our Sun runs out of hydrogen fuel, it can no longer sustain the outward pressure that balances the inward pull of gravity. The result is a gravitational collapse that causes the star's core to implode. For more massive stars, the same thing happens when they exhaust their nuclear fuel. However, the implosion of these massive stars is much more violent and dramatic. It's like dropping a bowling ball on a pane of glass. If the glass is thin enough, the bowling ball will simply smash through it. But if it hits a thicker part of the glass, it will cause the entire pane to shatter. In the case of stars, the thickness of the glass is determined by its mass. If a star is massive enough, the implosion will continue until the star's core is compressed to an infinitely small point known as the singularity. The boundary around the singularity, called the event horizon, is the point of no return for anything that ventures too close, including light. Not every stellar remnant becomes a black hole. Only those that are massive enough to overcome the electron degeneracy pressure, a quantum mechanical effect that resists further compression, will collapse into a black hole. The critical mass for this process is estimated to be around 3 to 4 times the mass of our Sun. When this happens, the star's core is mostly made of iron, but other elements like nickel, silicon, and oxygen can also be present. However, these elements don't play a significant role in the formation of the black hole itself. The surprisingly simple ingredients. So what exactly is a black hole made of? The answer might surprise you. Despite their reputation for being enigmatic and complex, black holes are actually formed from surprisingly simple ingredients. Contrary to popular belief, they're not made of any fancy exotic matter, but rather mostly from the same stuff that stars are mostly composed of: hydrogen and helium. These two elements are the most abundant in the universe, making up a whopping 75% of its baryonic mass. As a result, when a massive star explodes as a supernova, a significant amount of its mass is released into space in the form of hydrogen and helium. When another star forms from the remnants of this supernova, along with other elements that were forged in the stellar core during the star's lifetime, these elements will be present in the new star's composition. In addition to hydrogen and helium, stars can also be composed of heavier elements like carbon, nitrogen, oxygen, and iron. These elements are produced in the star's core through nuclear fusion reactions and are essential for the formation of planets and other solid bodies in the solar system. For example, carbon is a key ingredient for life as we know it, and oxygen is vital for the formation of water and other compounds found on Earth. While these trace elements are crucial for the development of planetary systems, they don't play a significant role in the formation of black holes. The illusion of complexity. You may wonder why then don't all stars turn into black holes if they're mostly made of hydrogen and helium, which is readily available throughout the universe. The answer lies in the true nature of black holes. They're not made of a specific type of matter, but rather a highly compressed form of matter that has been compressed to extreme densities. The most important ingredient in a black hole is its density, not the specific elements present. To understand this, consider the difference between a balloon filled with air and a balloon filled with lead shot. Both balloons are the same size, but the one filled with lead shot is much heavier because the lead is more dense. Similarly, a black hole can be thought of as a balloon filled with lead shot. The core of a star is like the air inside the balloon, and as the star collapses, it's compressed to extreme densities, like squeezing the balloon filled with air until it's the size of a basketball. At this point, the star's core would be as dense as a mountain of lead. When a star collapses into a black hole, its core is compressed even further, reaching densities that are unimaginably high. At such extreme densities, the star's original identity is lost. The iron, nickel, silicon, oxygen, and other elements present in the core no longer exist as separate entities. Instead, they're all part of a singular, infinitely dense point called the singularity. The boundary around the singularity is the event horizon, and once anything crosses this boundary, there's no return. Nothing, not even light, can escape the pull of a black hole's gravity. Black holes in the cosmos. Black holes are not only fascinating objects of study for astronomers, but also play a significant role in the formation and evolution of galaxies. They serve as cosmic architects, shaping the distribution of matter in the universe and influencing the dynamics of entire galaxies. Most galaxies in the observable universe have a supermassive black hole at their heart. These black holes can have masses ranging from millions to billions of times that of our Sun and play a crucial role in the growth and development of their host galaxies. Our own galaxy, the Milky Way, is no exception. At its center lies a supermassive black hole known as Sagittarius A star, which has a mass of about 4 million times that of our Sun. Despite their seemingly destructive nature, black holes are essential for the recycling of matter in the universe. When material from nearby stars falls into a black hole, it releases a tremendous amount of energy. This energy can then be used to form new stars and planets, continuing the cycle of matter and energy exchange in the universe. Studying black holes helps us understand the fundamental laws of physics and the behavior of matter under extreme conditions. By unraveling their mysteries, we gain insights into the nature of gravity, space, and time, and the evolution of the universe itself. So the next time you gaze up at the night sky, remember that hidden within the depths of space lie these enigmatic objects, reminding us of the endless wonders and complexities of our universe. And there you have it, folks. The elemental makeup of a black hole is surprisingly simple, defying the complex and mysterious image often associated with these celestial objects. As we continue to explore the depths of space and unravel the secrets of the universe, we're reminded of just how much there is left to discover. Thank you for joining us on this journey of cosmic discovery. If you enjoyed this video, don't forget to hit that like button and subscribe for more thrilling space adventures. Until next time, keep looking up and stay curious.